Okay, let's do piston ring gaps today. First thing, aim the camera at the engine. Second thing, mark each cylinder. So this is number 2, this is number 4, and this is number 6. Which means this is number 1, this is number 3, and this is number 5. Doesn't really matter which way we do it. Probably easier to see this side. Okay. The piston rings. As you can see, it's nicely marked. Top groove, second groove, bottom groove, or oil control. Look at the top grooves. Can't see any marks. Because normally if there's a mark, it shows the direction of the ring. For the second one, like this one, you can see there's a mark there. So normally that means that this is the upright. This has to face upwards. Top groove, doesn't seem to be anything. So there, going either way. And you've got a nice little instruction. Piston ring installation, as if we didn't know already. And as I said, any piston rings with a mark, this goes upwards. So, back to the engine. 6 new plastic bags. Put them in afterwards. So, we'll do piston number 2. Once we've done it, put them in the bag. Okay. Piston ring end gap. So 0.25 to 0.46. Since it's a turbo engine, we want it to be pretty much on the outer edge of the tolerances because we're going to heat the thing up a lot. 0.46. 0.46. 0.4 there. 2.5. 2.3. 0.4. 0.35. So these two together, the outer edge anyway. I'll start and see how it goes. push it down. Nice even. And measure it. Measure it straight away with a 0.4. That goes in nice and easy. 0.5. There. 0.5 is tight. Show you. No, this is not going in fully. 0.5 is it's not going totally flat. Don't know if that's right. No, it's not totally flat. Take 0.46, 0.4. Forms 6. .4 goes in, but 0.46 is a little tight. Just, yeah, that's nice. I can feel that. You can see that. 0.46. It's just not even binding, but it's just rubbing, and I can feel a slight drag. So you can say, oh, damn, the camera's going to fall inside that top ring. 0.46, absolutely spot on. So that one's good, in the bag. Second ring. Top upwards. Ease it in. Push it down a little bit. Just nice and square. And that should go maximum 0.79. My 0.7 gone. 6, 8, 5, 7. Okay. .7 is going in. Sorry, I'm misreading it. Maximum 0.84. .8. 0.8 goes in, but it's just a loose fit. And then .84. And that's spot on. Regard it can even hold the weight of the feelers. Show you again if you want. 0.84, the two together. And that's good. So this ring is good. Like I said, turbo engine, you want it on the outside edges of the tolerances, especially if you're going to push it. Sometimes you gap the thing even more by just slightly over the spec. They were right on the outer edge of the spec for the engine, and I think that should be okay. This one in the bag. And now the oil control ring. These are more complicated to do because they're little thin little things. Because it's a sprung loaded, what's a combined ring, made with two little scrapers and a wiggly bit in the middle. And there's nothing much you can do with the wiggly bit because it's just springy, but you can check these ones. Same technique. Into the ball. Push it down a certain amount. In fact, you're pushing it down the bore in pretty much the place where it's going to be at the top of the stroke. I'm pushing it down this distance. That piston ring gap point, oil control 0.76. Misread earlier, I think. 0.4, where is it? 0.7, 0.7. Too small. What they say, that's the upper edge. So it's got a large scale, it goes from 0.25 to 0.76. Let's see what we've got. Let's try. 0.5. 0.5 goes in. Bigger than 0.5. Let's try it. 0.6. 0.6 doesn't go in. try. Point 0.55. Point 0.55 goes in. Yeah, 0.55 goes in. So it's between 0.55 and 0.6. To be honest, I don't fancy filing these things. It's within spec. Slightly tighter than the top two rings, but prefer to control the oil a bit better than turbo engine is the heat. The heat's going to expand the ring more at the top, so you want to kind of allow for that. Second ring, you want the gas to escape out if it does get caught, in order not to push the rings apart. Oil control is much lower down, and anyway you've got holes in the piston for allowing the oil in and out of the oil control ring, so if there's gas caught, it's going to go through there. It's not just the gap of the ring, or not so much. Anyway, check the last one. Don't know if it makes sense what I've just been talking about. It makes sense to me, that's what counts. Huh. See that one? Oh, it goes in 0.6. Great. That one goes in 0.6. Let's try 0.7. I'll find my 0.7. That's my 0.7. That one goes in at 0.7, but it's a tight fit. Good. Yeah, there. Just binds up when I push it in. It'll do. If you can remember to put this one on the top of the sandwich. This one with a slightly bigger gap will allow any excess gas to go in. So. Yeah. We've checked the gaps, and that's piston number 2. Put this somewhere safe for when we do the rest of the thing. Okay. so good. Okie dokie. It's a good one. So, done half the block. It's lunchtime. The rest we'll do later. .6. Save. No. Good. Show you. This is the second compression ring. It's 0.84 max. There I've got 0.9. Doesn't go. See? Doesn't want to go into the slot. It's 0.8. Slides in nice and easily. So, you know it's between 0.8 and it's not quite 0.9, so find the little thin one wherever it's hiding. Hides behind the 0.6. Oh, yes it does. There it is. 0.84. .8 4 ding, but nice, just fits as it should. Slightly stiff. Good. That one's okay. Check the piston ring clearance and everything. This cylinder is very, 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 very slightly larger than the others by what's given on the piston ring gap. It's about, well, not even 5. It's not even 0.5, it's like 0.4, or 0.004, 4/100th of a millimetre bigger in some places. You might have just a slight more wear at the top of the thing, at the top of the stroke, but I can't feel it. That's the thing. I didn't measure it when we were checking everything, but there must be a little discrepancy. But it's very, very minimal. Like just less than 4/100th of a millimetre. That's like just 4/100th divided 0.004 divided by pi. That means the cylinder diameter changes by just over 1/100th of a millimetre. It moves more than that when it heats up and cools down, so it doesn't really matter. So it doesn't matter on our engine. Good. So just come down. So that's good. We didn't need a little disc ring filer. Everything was within specifications. So this can go back in the cupboard for the next 10 years and never be used. We've done this once, but we'll do it again. Phew. Number 2. These are all weighed. They're all the same weight. Which one shall I use for number 2? This one? Mm-hmm. Clean, fresh cloth. The pistons aren't directional, so there's no problem which way we put them into the block. Con rods are not directional either, but they have got a matching mark, and we'll just make sure the matching marks all face the same way. Brake cleaner again. Yeah, I should put a glove on my hands and cover myself in solvent. Probably not the best thing to do. The last time we checked the gaps in the piston rings, everything was good. Just to make sure there's nothing stuck to the surface. Since we're working in rather dirty conditions, you cannot be too clean when reassembling. So, clean cloth all the time. Fresh oil. Okay. Easiest. We're going to stop talking now because I need to concentrate on getting these in. Second ring. Make sure the dot faces upwards. Okay, that's good. First ring, or the fire ring. Now there's no up or down on these. They're identical, both sides. Double check. I already checked that one. Triple check, quadruple check. Don't force it too much because they are fragile. And try not to scratch the thing as they go in. Okay. That's one set of rings done. Double check that we're dry. I prefer to do one piston at a time, reassemble everything on one piston and put it in. If I do it in series I might forget something. I prefer to do one at a time. And if I get tired or whatever, come back to the others later, but at least I know I've finished one complete set. Still a bit of a, you can see where I check the bearing clearance, still a bit of a, what do you call it? You know what I'm talking about, plastic gauge. Check that 10 over. I already checked when I did the plastic gauge, but see what I'm doing. Loads of stuff in the way, but just want to lube it up. Let's bring the ring compressor. I'll be able to go over it and still slide. Going to put the rings at top and bottom ring opposite. I've already done the first and second ring opposite, and the oil control ring is already opposite itself, so none of the gaps line up. Normally it's 1/3, 1/3, 1/3, but since it's a double ring on the oil control ring, it's more so opposite, opposite, and then diagonal, diagonal. There's nothing binding one last time that I can squeeze them in by hand, and I don't feel any binding of the ring. That all seems good to me. Okay, that's in. The ring compressor. I'm going to oil the pin. Nearly forgot. Get a bit of oil to go down the oiling holes. Okay. Bit of assembly lube on the new bearing. Check my finger is clean. Same for the end cap. Okay. I've double checked to see that the bearing is spotless. So, moment of truth, let's stick one in. I'm going to stick them with, which way does the engine rotate? Can't remember. That way, maybe. I'm going to stick them with all the marks facing that way. It really doesn't matter. That's how I'm going to do it. I'm going to bring the crank up. I don't want the thing to drop down this go stunk. So I'm going to move this over. No, I think I prefer vertical. Don't know how I did it last time. I can feel down. The piston is in the bore. I don't know if you can see that, put that a little bit lower. Now the lighting's not great, but the conrod is in contact with the bearing surface. So ARP lube on the heads. So we said with the numbers all facing that way. Okay, they're just snugged down. You can move. Okay. Okay, so let's read the specs. ARP torque specs. Rods, torque specs. 55 foot-pounds with ARP lube. We'll do it in 20, 40 and 55. That seems like a good interval. See? $20, $40. $40, 50, 2, 3, 4, 55. Okay. Good. So that's one piston assembly in place. Everything looking good there. Keep it to the top of the... Huh? Good job. Let's see what the time is. Okay, that's 2 pistons in place. Whew, that'll do for now. Click, click. Ooh. Click, click. There you go. Wrist torque wrench.